Greetings, everyone. My name is Peter Young, and I'm president of Societe de Chimie Industrielle, and I want to welcome you to today's rather timely topic and speaker on the global semiconductor shortage. When will it end? This is a high-profile question and an issue, and everyone who's either trying to buy a car or electronics, so forth, is facing this problem, and we're very pleased to have our featured speaker today. Before I turn this over to Marc Reich, who is a board member of Societe de Chimie Industrielle and was the one who arranged for today's event, I'd like to cover two things. Most of you know about Societe de Chimie Industrielle, but for those who don't, we're a 102-year-old nonprofit that is focused on the life science and chemical industries. And we have three functions. One is we try to educate people on important issues. And this is a good example through luncheon meetings and webcasts. We give research scholarships to students studying chemical engineering, chemistry, biotech, as well as mentor programs to help them be successful. And we also have a career fair and forum that again helps students find jobs with important companies. And then we also give the International Palladium Medal Award to someone who has really contributed towards the industries that we serve. I hope all of you, those of you who are not members, we encourage you to join, and you get a number of benefits. And those of you who are members, I want to welcome you. And this has been a very exciting year because we went from 8 events 2 years ago to 20 events last year. And currently we're on track to have 28 events this year. But more importantly, it's not the number, but it's just the quality of the topics, because we've had sessions on ESG, sustainability, electronic vehicles, all sorts of things. What's the outlook, economic outlook, the supply chain problems. So I think one of the things we've been able to do is try to pick topics that are either important opportunities or serious problems for the industry. And this, for example, is a good example of a topic and a speaker that fits that criteria. Before I turn this over to Marc, I just want to mention the upcoming events. We have a webcast on October 20th, featuring the CEO, Steve Sommers of Vigon, a very successful and high growth producer of flavors and fragrance chemicals. And he's going to talk about nurturing growth and entrepreneurism. On November 9th, we'll have a discussion group on ESG combined with a virtual happy hour, which is a follow-on to the ESG webcast that we had on September 29th. I gather it's the ESG is such a headache problem. I guess coupling it with a virtual happy hour seemed like a logical thing to do. Then on November 16th, we have a wonderful speaker. We have Raj Gupta, who is a chairman of the Vantor and formerly the CEO of Roman Haas and a board member of DuPont. And he's going to talk about the art of transformation because he has been involved with the transformation of a number of well-known companies. So those are just the ones coming up, and we hope that you will attend those, and you can look at the events that are coming up on our website, societe.org, and also we have an events calendar where you can register. So with that, what I'd like to do is I'm going to turn it over to Marc and to Arnand. And the last thing I say is they will have a Q&A session at the very end. And the way you ask questions is there is a messaging function. And if you click on it, and then there's a section called Q&A. And if you type in your question, then the speaker and Marc Reich will be able to see the question. So, Marc, go ahead.
Yeah, thank you very much, Peter, and thank you everyone for being here today. Especially grateful to have Arnand Nambiar join us to talk a bit about what's happening in the semiconductor space. I think he's ideally suited for the task. Arnand, just to give you a bit of his background, He's global head of semiconductor materials at EMD Electronics, business of Merck of Germany. He's assumed this role in 2018. Prior to this, he was managing director of healthcare at Merck India. He's though had a number of jobs related to electronics, including managing director of Optronics, of the Optronics division at AZ Electronics Materials, Hong Kong, and vice president of operations, Cascade Microtech, and associate director of quality at Nikon Precision, which, as I recall, is a scientific instrumentation unit, is it not? But well, let's hear a little bit from Arnand. I think he'll start off a bit by just basically telling us the importance of semiconductors and what the role of semiconductors are in mobile phones, robotics, healthcare, autonomous driving, processing data. We learned just the other day that Apple is constrained in its production of the iPhone 13. Word is they may come short about 10 million of the 90 million they plan to produce in 2013 because of the chip shortage. And so, Arnand, please tell us a little bit about the importance of semiconductors in the electronic space.
Thank you for that kind introduction, Marc. And it is absolutely a very exciting topic these days, considering where Peter started off with basics like getting a car these days. It seems to be quite problematic. But as you rightfully said, you know, right from when we wake up in the morning to an alarm clock or your phone, to the toaster oven, to the fridge, to the car, and right till you go to bed, there's electronics and the semiconductors all around us. And right from the, like I mentioned, the garage door opener to your smartphone, which is almost a supercomputer these days, considering the advancements in electronics. Every electrical appliance that we touch today has a semiconductor in it, and we see that content increasing quite dramatically depending on the type of product we're looking at. If you think about a car these days, the semiconductor content is increasing almost 2x in the last few years.
Anand, shall I bring up that slide you have on the subject?
Absolutely, yeah, you can bring that up. And it's just to show the slide that you'll see here is just to show the proportion of increase in some of the key areas in the semiconductor industry, such as automotive and smartphones and laptops. And this is just a simple piece of the puzzle, because we can see that across the board, every electronic device digitally enabled is requiring more and more sensors and memory and processors and so on and so forth. And this content will continue to increase as the appetite for more data and the appetite for more photographs and memories to be created is prolonged. And you know, you can imagine a photo that you take today needs to be present 30 years from now. So all of this goes into storage devices that is required. And so the enormous amount of momentum created by the need for more data and the need for more digital tools translating into more and more semiconductor content in consumer electronics or automotive or data centers and so on.
Very good. I mean, could you tell me a bit about the types of materials and chemicals that EMD supplies? I mean, you don't actually make the chips, but you supply a number of the materials. And I think it's important that we get a sense of your position within the semiconductor continuum and how you aid the production and development of semiconductors.
Yeah, thanks, Marc. Maybe I'll take a couple of minutes just to explain who we are. I'm part of EMD Electronics. We are a business of Merck KGaA in Darmstadt, Germany. And we have three business sectors that we focus on. And if you can go back to the prior slide, Marc. just to explain the businesses that we are in, to take 30 seconds, we are in three business sectors: healthcare, life science, and electronics. Healthcare is the traditional pharmaceutical industry, where we make oncology, immunology, and immuno-oncology products, primarily in that space. Life science is where we cater to the pharmaceutical industry, so anywhere from drug discovery to drug manufacturing, and all the ingredients that go into it is supplied through our life science business sector. And electronics, excuse me, electronics, which I'm part of, is primarily focused on the electronics market, 90% of it, and 10% of it into a surface coating business. And the next slide shows you the naming convention and our uniqueness in the world. There is a lot of confusion around our name and what we're called. We are unique in the way that out of the 193 countries, 191 countries recognize us as Merck. And in the US and Canada, we are known as EMD Serono in our healthcare sector, Millipore Sigma in our life science sector, and EMD Electronics in our electronics sector. So I'm part of the US operation, and we are known as EMD Electronics here. So in terms of where we play in our electronics business, we have three business units: Semiconductor Solutions, which we will talk a little bit more about, Display Solutions, and Surface Solutions. So if you think about a smartphone, Semiconductor Solutions is everything that goes into the brain of the smartphone. Display is the user interface, the screen, the OLED screen or the LCD screen. And surface is the aesthetics of the smartphone. So that's how we would describe ourselves, as immersed into and integrated into every electronic possibly in the world, especially the ones with displays and so phones and so on. So we play a very integral part in the semiconductor value chain, whereby if you think about a smartphone maker like Apple, who starts building a new iPhone, they start with the brain of that iPhone. What is the processor? What type of memory do you need? What kind of features do you need in that phone? And the Apples of the world will work with companies like TSMC and Qualcomm to design the chip and manufacture the chip. And we supply the materials to TSMC to manufacture the chip. And we're one of the key material suppliers in the value chain, supplying to pretty much all of the semiconductor manufacturers in the world.
In the case of TSMC, you're referring to Taiwan Semiconductor.
That's correct. That's correct. In terms of our electronics business itself, Marc, as I mentioned, we sort of touch every electronic in some form or fashion. And our electronics business is roughly 3.5 billion euros. And one of the most important parts of the electronics business is the innovation model and the investment into R&D. We're one of the leading R&D spenders in the world. And as a result of that, we're also able to play in some of the most critical components and critical manufacturing segments of the semiconductor value chain.
And so you have a number of R&D facilities globally. I think you have one in Japan, Shizuoka, Japan, Tempe, Arizona, Shanghai, China. So you're pretty much globally positioned.
That's right. The semiconductor industry is primarily present in the US, EU, certain countries, in China, Japan, Korea, and Taiwan. This is primarily the geographies where our semiconductor manufacturers are present, and these are our customers. And for these customers, time is everything. So how quickly can they introduce a new product into the market, and how quickly can they build release it into the market faster is everything. And for them, localization of R&D and production is extremely important from a business continuity as well as technology development perspective. So we are present in pretty much all of those geographies, very close to our customers, with R&D applications and several manufacturing facilities.
Is the nature of the R&D mostly technical support, or how much of it is actually devoted to, say, blue sky research, breakthrough research?
Merck and EMD being almost a 353-year-old company, we put a lot of emphasis on long-term value creation. And that entails taking bold risks, looking at the future. As I mentioned earlier, we spend roughly 8% of our sales on R&D, and globally that's present in these geographies that I mentioned, pretty much in a lot of research done in the U.S., Japan, a lot of development work done, of course, in the U.S. and Japan, China, Korea, Taiwan. So depending on the product that we're looking at, there are different complexities and different type of footprint that we get involved with.
Very, very good. When we talk about the semiconductor market overall, globally, how large a market are we actually talking about?
The overall semiconductor market itself is roughly 600 billion euros, $600 billion as of 2021. And this market is growing quite dramatically over the last couple of years, as we all know it. And the inception of all of this is coming from the fact that 5G and the adoption of AI coming into 2020 and 2021 has been an enormous has put an enormous amount of pressure on the semiconductor market itself, and translating that into an enormous amount of growth. And with the adoption of AI and with the implementation of 5G, and you add on top of it the pandemic that accelerated a lot of the digital adoption that would have that would have otherwise taken 5 or 10 years from now, has really put an enormous amount of pressure and demand on the market itself. So the growth that we see probably will continue on for the next several years, with possibly some ups and downs that is sort of cyclicality in the marketplace. Nevertheless, I believe that there is a long-term demand horizon that we see as a very stable growth pattern for the industry, and we see that already from 2020 to 2021. And looking at 2022, we expect also a very strong market.
Your slide suggests that there's been an increase, of course, of 22% from 2020 to 2021. Do you expect a 20+% increase in the ensuing years annually? Will this moderate somewhat once the shortages that we're reading about have ameliorated? But how long can this 20% year-over-year increase continue?
That's a $1 trillion question, because there is an expectation that the semiconductor industry probably will hit $1 trillion by 2025. And this growth has been, it's, over the last decades, the growth of every 500 billion in the industry has been accelerated. So this translates into a question that you asked, is this sustainable? How long can this go? And I think we have to ask ourselves, how the digital adoption is happening these days. If you think about all the data created in the world, recently a Credit Suisse analyst described this quite well. Of all the data available in the world, only 2% of it is actually analyzed and value created out of. And so you can imagine that companies around the world are just starting to put investments into understanding data mining or understanding data science. And as companies put investments into it and realize value, there will be more investments going into data science. So therefore, you can imagine if this 2% becomes 4% or 5%, and the amount of data that's needed to be created in order to be analyzed. It's a circular logic, and there will be more and more data created, and therefore more and more data storage needed, more processing power needed, more interfaces needed. And therefore we find ourselves that when we look at this market, we know the trend is going to be a long-term growth trend. And there might be some ups and downs in the middle. However, the two endpoints for the next decade will be very, very strong, probably in the double digits. And the market itself has been upgraded by various external reports to say it is going to grow in the 8 to 10% range. So we do see a very, very strong long-term demand profile out of these digital acceleration, out of AI adoption, out of 5G implementation, and so on.
So as you envision this long-term demand growth, you still have the present constraints in the supply chain of getting those chips out there. Not enough capacity, apparently, to satisfy Peter's requirement for a new car, perhaps. But we know about these shortages. We've heard about Toyota, General Motors, and Ford cutting back production because they've had chip shortages. Just to step back for a moment, how can we understand the present shortage? Where did it come from? What role does COVID-19 or has COVID-19 played in the limitations on the market? When will we see production increase, and what do the fabs have to do, and what does material supplier like Merck have to do to see that demands are met?
Yeah, it is quite a complex situation. However, it's also basic economics that is at play. If you were to look at the economic factors, there's a very high demand in the marketplace and a very limited supply. And therefore, you see this very unstable situation where there are rising prices as well as shortages in the industry. And then let's go back and ask ourselves, okay, why are we in this situation, and why, what does it take to get out of it? And it goes back to sort of the discussions that we had about 5G and AI adoption. As processing power has become better and better over time, AI adoption is more and more. So the industry was getting ready and ramping up for this 5G implementation, as well as the additional AI adoption that was expected in 2020. And so therefore, the industry was coming out of the recession in 2019. There was a lot of investments into data centers, and hyperscalers were ramping up, tooling up these data centers in 2020. And alongside the expectation that smartphones are going to pick up with the 5G adoption as well. So the industry was gearing up for that. And here comes the pandemic, where initially there was a big scare globally, by looking at all the photographs we remember from China, that there will be a prolonged economic shutdown. And automakers clearly took a view of that and cut POs in many cases. And in that situation, when the economy stopped and started working from home, there was an accelerated demand for PCs and home gear, gaming consoles, and you name it. And so therefore, the industry shifted very quickly to supply to that demand, while there was a cancellation, if I could call it, from the automotive market. And this continued on until, of course, the automotive market came back on to look for a product. And of course, at that time, the capacity has already been fully utilized by our customers to serve other markets. And then you add on top of it a lot of logistical challenges that the world has faced in the last 18 months. Suez canals, earthquakes, fires, and you name it. And on top of that, we have a global logistical bottlenecks in a lot of major ports because of labor shortages, because of COVID, and so on. So you add all these complexities in the supply chain with limited capacity throughout the value chain, not just our customers, but also material suppliers and OEMs that make equipment that go into semiconductor manufacturing are all constrained by the similar situation. So we're all making that effort to ramp up our capacity, and including our customers. And they've announced in 2022 itself about 115 billion of capacity expansions that our customers have announced, and that translates into equipment capacity that's needed, material capacity that's needed, and so on in the value chain. And this is, in my humble opinion, a slow and linear process. You cannot get capacity expansion of 2 or 3x overnight, and this takes time for the entire value chain to catch up. And so I believe this shortage or this sort of instability will probably last us for another 6 or 18 months, or could be even more if the demand continues to be at this pace. And given this increase in semiconductor content, we are at Merck taking that view that this market is going to be continuing to grow at a very rapid pace. And we recently announced a $3.5 billion investment for over the next 5 years in capacity and R&D to help our customers, support our customers with adequate capacity and materials to serve the end market. Sorry, a long-winded answer to your question.
No problem. It was a long-winded question. But the $2.5 billion commitment, that's in electronics alone?
Correct. A $3.5 billion investments in electronics, and a significant part of that will be into the semiconductor materials and equipment space.
And that's over how many years? I'm sorry.
Over the next 5 years.
Okay, all right. So that's a significant commitment. How much of an increase is that over what you previously invested over the previous 5 years?
Orders of magnitude. It is because one, we have grown from it's probably important to understand the history of Merck into the electronic materials space. We've kind of built the right to play in the space over a 100-year period, starting with liquid crystal research and entering into the electronic market with a liquid crystal product, which is still one of the market leaders in the display area, focused on LCD, LCD, and then now in OLED manufacturing. And over the years, Merck, the first entry into semiconductors was through the acquisition of AZ Electronic Materials. And AZ Electronic Materials is one of the pioneers of photoresist, launching one of the first positive tone photoresist back in the 1960s. So a long history of involvement in the semiconductor space, and AZ coming into Merck was the first sort of entry point back into niche high-end electronic materials for semiconductor market. And over the years, we've gone through several very strategic acquisitions, starting with the Sigma Aldrich high-tech business, supplying organometallics into the precursor business, with Ormet Circuits getting into the packaging space, with Versum Materials kind of enhancing our portfolio in thin films and CMP and specialty gases, and intermolecular to help us get a step further into materials innovation through electrical characterization of our chemical products. So, a various series of steps that we've taken to embolden our presence and also our position in the marketplace to support our customers.
Among the more recent acquisitions was the one of Versum in 2019, but about a $7 billion acquisition. What did that actually do for you at the time?
Yeah, prior to the Versum acquisition, Merck's presence was primarily in the lithography space, and we had a small thin films business as well as a small CMP business. Versum had a very complementary portfolio where they were very strong in the thin films and CMP and specialty gases, and the addition of this portfolio brought us a very unique ability, one of very few material suppliers in the industry that's present in every major manufacturing process in the industry. And so therefore we have a very unique view of our customer base and how they use our materials, how the manufacturing process is different between customers, and how best we can support them to really solve some of their real complex problems. We come from the world where material supply base was very focused on individual technology segments. So we have a lot of companies very focused on lithography, a lot of companies very focused on thin film, focused on CMP and so on. And we're one of the few companies that have our foot in every technology segment. So we're also seeing that a lot of the complexities that our customers face with regards to yields and with regards to time to ramp and so on has to do with integration. There's so many different materials that are interplaying with each other. The complexity of making all of this work with the right level of power, performance, area, and cost is a very, very challenging task for our customers. And the onus is on our customers to integrate all of these complexities and come up with the right solution. And we believe that we have a unique ability to work even closer with our customers to solve some of their integration problems, because we are the ones supplying the precursor, and we are also supplying the slurry that polishes the precursor. So we believe that we can help our customers even further by working closer with this portfolio that we have. And the acquisition of Intermolecular. The acquisition of Intermolecular brings another unique capability whereby we believe as material suppliers, our responsibility is not just supplying a chemical in a bottle, but rather an electrical functioning film. And what that means is, even though we sell chemicals, our customers are creating electrical devices. So can we characterize our materials electrically before we, in our innovation process, in our quality process, and so on and so forth, is what gives us the inspiration that we can even get better shots on goals with our customers and reduce their iteration, reduce their time to ramp by characterizing and validating our materials electrically. And that's another unique capability that we've acquired through Intermolecular, and we're using that to help speed up our innovation cycle.
Now, as you do this and improve the innovation cycle, improve the quality of materials, supply customers what they need to supply automotive, mobile phone makers, and so on. I mean, how long then will the current shortage last? What is, holding it back? I guess there are a number of new fabs in production now, under construction, where the chip makers will produce new semiconductors. How long until their capacity builds, and yours as well, to meet current needs and future needs?
Our customers have announced, there's a lot of announcements lately with regards to capacity expansions and fabs. And of course, these fabs are white space that's going to be created, a lot of big shells that need to be populated with equipment, and then we need materials to go into those equipment to actually create the chip. While the customer expansions, of course, are announced, they still need lithography machines, they still need etchers, they need coder developers, the OEMs that manufacture these, like ASML, AMAT, Lam Research. All these companies need to also ramp up their capacity. And then if you think about their value chain of all the parts and bolts and optics that's required to create all these equipment, all of them need to ramp up their supply chain as well. And that's on the equipment side. And if you think about the materials side, we have specialty gas plants, we have highly toxic chemical plants, very dangerous materials. We have plants all across the globe that require capacity expansions almost 2x in the next 4 or 5 years. And these plants are quite complex and quite challenging to ramp up in a short period of time, starting with safety requirements. How safely can we produce these materials? How safely can we ramp up these materials? Quality of these products. Every batch for the next 10 years need to be at the same quality level or improved over time for our customers. You cannot have a single batch failures. It's just impossible, or it's zero risk approach for us that we would be to have a quality incident. And then cost, as the material prices are increasing, how can we maintain cost? So all of these components coming together is relevant for the industry and is important for the industry to understand, to catch up to the demand cycle. So as I mentioned earlier, this is going to be a linear process because the entire supply chain needs to ramp up with it. And so therefore, the footprint expansions that our customers have announced is over a period of time. And over the next 3 to 4 years, there's been several fab announcements by the major customers, but we expect that to continue over the next 5-10 years, continued expansions as this digital acceleration continues.
So it doesn't seem like the shortage is going to end anytime soon. You can't say 3 years or 4 years or even 5 years from now.
That's the simplicity of economics is also that prices don't ever continue to go up forever, because customers always have an alternative. At some price point, the customer says, I'm not willing to pay for it. And at that point, the demand switches to the alternative available, and then prices will drop. So I think there will be a period where global economies, as they come back online, travel starts, or and if it does, I believe there will be further demand created for other goods and services. Tourism might come back, business travel might come back to some extent, et cetera, et cetera. So there is a continued demand cycle that is already there because of the work from home economy and the digital adoption. However, there is also further economic growth possible from other sectors. How does that translate to some of these sectors that might not grow? So PCs have always been very stagnant, except last year. Now there is an expectation that PCs will stagnate further in the next couple of years. How does that offset in terms of the automotive industry, or et cetera? So these are a lot of questions that come to mind. But the fundamental again is supply chain needs to provide enough products to the marketplace in order to meet this demand. And I think there will be some demand correction and supply correction over the years. But I think what we can be very confident about is the fact that these two endpoints over the next 10 years will be at a much higher pace than what we had expected in the past.
So it seems like, no matter what, though, semiconductors is still going to be demand in, if it's mobile phones, if it's 5G, if it's automotive, if it's in electric vehicles versus internal combustion engines. And then, what will be the response of the industry, I guess, is the ultimate question. And how will demand come into balance with the ability of companies, of chip makers and suppliers such as yourself for materials to supply demand? And it doesn't sound like that's going to happen anytime soon. It also sounds like costs will be going up, and you'll be seeing a rate of inflation increase. But can improvements in chip architecture, in chip efficiency, somehow or other mitigate a potential increase in prices for semiconductors?
That's a great question, Mark. I think we we have to, if you look at the technological progress in the semiconductor industry, the Moore's law, as we know it, is still very alive and kicking. And there's been more predictions about when Moore's law is going to die than we can probably imagine. Nevertheless, the industry has always found a way to continue innovating and meet those performance, power, area, cost requirements of the end customer. And if you think about that in terms of what is required for the industry to innovate, and how the value chain is investing into continued innovation, the industry has made an enormous amount of progress and continues to make an enormous amount of progress. In memory, for instance, in 3D, in NAND, in flash memory, we've had where the industry has flipped from a horizontal structure to a vertical structure, to a 3D structure. And we can imagine even logic and DRAM could even go into those 3D structures. So there is innovation continuing to happen, whereby the industry continues to innovate and push and continue to meet Moore's law challenges and push products out which are allowing us to have these supercomputers in our hands and allowing us to imagine autonomous driving and so on and so forth. And then you think about what else is what else could be happening in the industry, and we haven't even talked about neuromorphic and quantum computing, for instance. And you'd asked earlier, Marc, what is Merck doing to look into those kind of areas and futuristic long-term horizon. And we do have we spend almost 10% of our R&D in long-range research. So aspects like neuromorphic and quantum computing is very much on our table to investigate and find out what kind of material requirements will be there for those industries. And neuromorphic is very much in sort of the horizon, because we can almost see sort of the hybrid of neuromorphic in compute memory in some of our latest smartphones. So it's very much on the horizon, and very much a possibility to see in our lifetimes. And we may not be able to have a quantum computer in our homes soon, but some of the recent Google's announcement for their Sycamore processor, they claim they can do a calculation in 200 seconds, which took the world's fastest supercomputer would take 10,000 years to calculate. So these are some enormous and amazing progress being happening in the world, where we are absolutely being present and working through to find the material requirements to create these processors. And I think that's I would say the beauty of this industry is as we progress through various different transistor technologies that you're showing here, various different memory technologies, various architectures, whether it's a different type of computing itself, neuromorphic or quantum. Being a materials player and being involved in all of these technology segments gives us a very unique and a humble position to be able to be involved with all these amazing inflections that we're seeing. So perhaps I'll stop there. It's a lot of excitement for us, and I can go on this topic all day long.
Just one quick clarification. What do you mean by neuromorphic?
Oh, that's so the traditional PC that we have today is what we call a von Neumann architecture. It's where a logic and a memory is talking to each other in terms of when a computing calculation is done. So your data is stored in the memory, and the processing is done in the CPU, and then there is the data transfer between these two devices to get the calculation result. And this is what we call a von Neumann architecture. And the problem with this is, as computing power and computing requirements are getting higher and higher and higher, the transfer of data between this logic and the memory creates a bottleneck. And that's what we call sort of the von Neumann bottleneck. And the inspiration for Neuromorphic is to bring this together and remove this bottleneck altogether. And the inspiration is right here in our brain. Our brain works like an in-compute memory, and how do we get to as close as possible to the brain is really the inspiration here. And if you think about how a brain operates at just 20 watts of power, and whereas you need 200 watts for a little chip in our phones, it's incredible inspiration. And I think we at Merck, we feel very excited about the fact that there is probably even in the future a convergence of biology and electronics, and it's also around us where. Fortunately for us at Merck, we are very present in the life science and healthcare space, and we are very present in the electronic space. So we also see some convergence of this in the future, where you are going to see bioelectronics coming more and more into the forefront. So for us, it's even more exciting because that requires more semiconductors and it requires more materials, and therefore exciting times for us.
And now, before I open up to questions from the audience, I just wanted to make sure that we covered one important aspect of this webinar, and that is to discuss the influence governments have in convincing chip makers to localize production. We already know that the US and China are vying for economic leadership, and technology is essential to their notion of national and economic leadership. The US Senate had proposed investing $52 billion in the semiconductor research in the US. I know China has made similar proposals for upping its investment in the semiconductor chip industry and technology surrounding it. Where does this put us in development of new technology? Is this a positive? Is it a negative? How does it actually benefit or perhaps detract from the development of technology?
I think it's the governments definitely are waking up to the importance of semiconductors to national security and beyond. And if you think about today, possibly the warfare or even probably conflict in the future could be very much driven through economic means or digital means. Cyber security, all of that is a very critical topic these days, and there is certainly national interest to make sure that countries, governments, militaries are very safe in that manner. So governments are certainly realizing that is a very key aspect of making sure that they own that piece of knowledge base and they can control for national interests. And so, of course, the U.S. government and China have been very vocal about their national interests, and therefore it's more in the news. But it's no different than what Japan feels about it, or Korea feels about it, or Taiwan feels about it. Primarily all the major semiconductor manufacturing countries, and also the superpowers like US and China. Having said that, I mentioned that the semiconductor industry has grown and has innovated because of its highly integrated supply chain. It is able to pick from the best of the best in terms of innovation, in terms of material development, equipment development, process development. The best of the best scientists work on these problems, and that's how we've been able to progress in this marketplace. Of course, there is a business continuity aspect of it, where customers want more and more local production to happen, so that there is less business continuity risk. And I think that's less of a political issue and more of a business continuity issue for businesses. However, with the governments realizing the importance of semiconductor technology, it's easier said than done to say we are going to have it all locally inbred, because the supply chain is highly integrated globally. Nevertheless, I think from a business continuity standpoint, what we do as suppliers is to make sure that we do manage supply chain. We do have business continuity management in place. We have inventory and production at those countries to avoid in the uncertainties of geopolitical tensions, uncertainties of logistical logjams, and so on and so forth. So while to summarize that question, I think that's a tall order to have every supplier and equipment maker in country to supply to that country's semiconductor industry, because it is a very integrated and a globally integrated supply chain.
Very, very good. Well, let's try and shift to one or two of the questions. I guess, don't have a whole lot of time left, but I think one person here was interested in knowing about what is the part of electronic materials supplied to the U.S. compared to Asia and Europe? I guess this is from Luc Verdet, but I guess more at just materials alone. I guess we're looking at a question that wants to get at how do you break out geographies and what role, where are most of the semiconductors and materials produced? And I think you did have a slide here that tried to measure the semiconductor market.
Yeah, it's
Oh, I'm not getting people busy. Here we
you got a slide 14. The slide 14 will just give you the semiconductor market itself, where it's present today. That is our semiconductor makers. So of course there's a lot of domination in APAC, given the presence of semiconductor industry in Korea, Taiwan, Japan, and China. And so that's a little bit kind of lopsided view to look at the market, but nevertheless, there is a lot of presence in APAC, and then to some extent the Americas and Japan and EU is some similar situation. The materials industry and OEMs are, of course, they're spread, but there's a lot of dominance in the US and Japan for that industry. And in our case, we are present very sort of uniformly, I would say, between US and APAC. Of course, we, depending on the type of material and the type of product that we're talking about and the type of segment, different levels of presence in different countries. So it's very hard to demarcate and say, what is the presence level in different countries.
Very good. I think we have another question here of, let's see, from David Horowitz. Will the new generation of semiconductors require further tweaking of current chemistry and lithography? Or are we in need of a totally new way to create computing hardware? And then corollary to this, is nano just more of what we do now, only on the next smaller scale versus other technology?
Absolutely. I think if you look at maybe a couple of decades ago, we would probably be using about 7 or 8 elements in the periodic table. Today, we're researching or using 50 to 70 elements in the periodic table in some form or fashion. I think there's a high level of need for the industry for newer materials, for more sustainable materials, and for more sustainable products at the end of the day. So beyond just performance requirements, there's an enormous need for us to create a more sustainable product line, a more sustainable process in order to make sure that that is also a key aspect of future growth. So in terms of computing, I was earlier alluding to the fact that the von Neumann computing and the future in terms of neuromorphic computing research and quantum computing research is very much very much I wouldn't even say a long-term horizon. I would say sort of mid-term horizon aspect that is developing in the marketplace.
Very good. Now we've got a question here, I think, from one of your colleagues, and I hope I've got her name pronounced correctly, Sakrit Kahara. We'd like to get your thoughts, and in your opinion, what should we do differently to resolve global economy supply chain issues, such as a shortage of truck drivers, which has led to congestion at the ports?
I wish I had a very smart, clever answer for that, but I share the pain because I was recently at Portland, Oregon airport, and the rental car company wanted to charge me $700 for a night for renting the car, and it was because there was a shortage of people to clean the cars and shortage of people to man the gates and so on and so forth. And I think that's it's an issue that we're seeing in logistics ports across the board, particularly in between the U.S. and China. And I think there is a equipment shortage as well as labor shortage, and I think the labor shortage, we're all hoping that the pandemic and we get out of it as soon as possible, and that's the only sort of light at the end of the tunnel I can see, that where we can bring people back to work, and there's some level of stability back in the economies where logistical catch-up, equipment, containers actually being produced. There's companies have ordered more containers to be built, more lines to be open, ports to be manned appropriately, and so these challenges are not short-term, and that's why I mentioned it would probably take anywhere from 6 to 18 months for some of these issues to sort of stabilize before we can say yes, now we're in a situation where before we can say we're in a better situation.
Very, very good. Another question from Kurt Martinson. What sort of innovation is going on at the printed circuit board at that level of manufacturing?
Well, maybe, I'm not the expert in the PCB area, but what we can talk about a little bit is the whole area of heterogeneous integration. And more companies, as you can imagine, Apple's and Nvidia's and Facebook and Amazon, they are all designing their own package. And while a company can make a very high-end leading-edge processor, you also need to marry a whole bunch of other units to create the right product for those customers. So heterogeneous integration is becoming a key aspect of delivering delivering to the power performance area cost requirements of our customers. And so in this space, definitely a lot of innovation happening when it comes to materials requirements, a lot of need for newer type of processes, a lot of need for, in the whole space of advanced packaging, there's an enormous amount of growth. And we also are playing very strongly in that space. Having said that, it is still highly challenging to have a multiple devices packaged into one system on a chip, and so innovation is still very, very prevalent. It's a high growth area, and that's one space that we're active in. Unfortunately, not specifically PCBs.
Very, very good. I think we're just hitting 2 o'clock now, and I think we traditionally call an end to these webinars at that time. Peter Young, are you still online, and would you like to?
Yeah, I'm. If you can unshare the slides for a second so they can see everyone.
There we go.
Okay, wonderful. First of all, I want to again thank Marc for arranging the speaker and Arnand for a wonderful speech. We had a very large number of people log in, so it's a testimony to how important your topic is, and they stayed logged in, which means that you captured their attention. So I want to thank both of you, and I wish his prediction was not quite as somber, right, about how long it would take, but that is the reality with lots of things in this world in terms of shortages and supply chain problems that we're having in so many different areas. So I want to thank both of you. I want to thank the audience for attending and the really good questions you're asking. And we look forward to seeing all of you at our next couple of events. Thank you very much. And we very, very happy to have all of you here.
What about our ballroom and table session?
Oh, well, okay, we're going to do that. And I'm sorry, you're absolutely right. So those of you who want to be involved with the networking session, in about 2 seconds, you're going to find yourself in the electronic ballroom. And Anand will be at table number 1. And if you want to sit at his table, just click on a seat. But otherwise, if you want to just mingle with the other people who are in attendance, just find a table. And when you click on the seat, suddenly you're going to see everyone like we're seeing the three of us, and enjoy the conversation. And we'll let the networking session go on for about a half an hour, and let all of you meet with each other. So thank you all.
Thank you, Peter. Thank you, Arnand.